Okay, welcome. This is for the Unit 2A test review. In this particular part of the video, we're going to go through questions either 1 through 9 or 1 through 10, but we'll get through the graphs in this part of the test review. There will be other videos to follow. So which of the following describes a continuous variable? All right, remember a continuous variable, that's the key word, is continuous here. A continuous variable is a variable that can take on any decimal number. In other words, it is not going to be a counting number. It could be, but it can take on any decimal number. So the number of items sold at a craft booth for one day, that's probably a whole number value, like as we sold 3 items or 4 items. We probably didn't sell 3.73621 items. So that one, probably not our best bet. The number of apps downloaded, probably not the best again, because hopefully you're not downloading part of an app. The diameter of a tree trunk. Now, diameters and measurements and weights and things of that's probably a good idea as to what we're looking for as a continuous variable here. And then we have the number of baskets made. Well, you're going to make a whole number of baskets, so that's not going to be it. And the shoe sizes. Well, most shoe sizes don't take on odd decimals. You usually don't have a size 3.24. So that's not it. So our best answer is going to be C. Part number 2, data will be collected on the following variables. Which variable can be considered discrete? Now, discrete is a whole number or counting number. All right, so it's going to be a nice whole number response. So the height of a person. Well, heights of persons can be very fractional and go out very far decimally. So probably that's more of a continuous. The weight of a person, once again, that can be fractional or decimal. So that's probably a continuous. The length of the arm span, it's a measurement. Measurements generally fall into the continuous category. The length of the time it takes for a person to solve a puzzle. Time, probably going to be continuous. That's a question mark, but look for the best answer. Because usually you could say how many hundredths of a second. So it's probably not going to be that. That's probably going to fall into the category of continuous. And the number of books a person finished reading. That's probably a good whole number, which would make this our best answer for discrete. So data were collected on 100 United States coins minted in 2018. Which of the following represents a quantitative variable? Now, please remember that a quantitative variable is measured numerically versus a categorical, which can be some sort of characteristic. So the type of metal made, that is not a numerical measure, that's a characteristic. The value of the coin. Well, coins can be 1 cent, 5 cents, 10 cents, so that's numerical. So this could be our answer, but remember, we're always looking for the best answer. The color, oh, that's a quality or characteristics, that's not it. The person depicted on the face, again, that's an identifying characteristic or quality that's not numerical, so that's non-numerical. And the location where the coin was minted, again, non-numerical. So our best answer is B, the value of the coin, because that is measured numerically. Which of the following questions about cars in a school parking lot will allow for us to collection as a set of categorical data? So now we're looking for non-numerical data. We're looking for data that describes a characteristic or quality that's non-numerical in nature. Well, how many blue cars? Believe it or not, even though we're looking for blue, it says how many, which is a number. So this is probably not our best one, but we'll put a question mark by it because it's numerical. What are the gas mileages in miles per gallon? That's definitely numerical. What are the weights in pounds? Okay, again, we're measuring, so measurement is going to be a numerical. What is the number of cars in a lot without a state license plate? So again, we're numbering, so a numerical. What are the color of the cars? Oh, this is definitely, because now we're not looking for a number, We're asking for the colors. So we're asking for a quality characteristic. So E is our best answer. And once again, this said how many, so it was looking for numerical. And so that's why A was not our best choice. All right, moving on to some of the graphs. In a certain school district, students from grades 6 through 12 can participate in a school-sponsored community service activity. The following bar chart shows the relative frequencies, and this is the key word, relative frequencies of the students from each grade who participate in the community service activity. So what we have over here is percentages. So 10%, 20%, 30%, 40%, 50%, and 60%. So which of the following statements is supported by the bar chart? The greatest number of participants. Well, in this particular case, we're not talking about number, we're talking about percentages. So we don't know how many ninth graders there are. Yes, they have the greatest percentage, but we don't know how many of them there are. There might be 100 ninth graders, in which case about 55 of them, but there might have been 1,000 11th graders, in which case 500. So we don't really know the number, we just know the relative frequency or the percentage. That's not my answer. And by the way, I need to always make sure this is supported. The number of participating students in grade 6 was equal to the number of participating students in grade 7. Once again, they're talking about the number, and we don't know how many are in grade 6, grade 7. Yes, we can see the relative frequency is the same, but we don't know how many there are. 30% and 30%, but maybe there's 100 sixth graders and 200 seventh graders. We just don't know. The relative frequency of all participating students in grades 6 and 7 combined was 60%. No. 30% of 6th and 7th graders. We can't just add from the columns. All right, so we can't do that there. Grade 12 has the least relative frequency of participating students. Here they're asking us about relative frequency, and by golly, theirs is the lowest. So D looks like my answer. And grade 11 had the greatest relative frequency of participating students. And we look and no, grade 9 had the highest. So my best answer here is D. All right, continuing on. A sample of 100 students from Liberty High School and 60 students from Central High. This is really important. So Liberty High School has 100 students and Central High School has 60 students. So consequently, we actually have some numbers to work with. All right. We're asked what they plan to do after graduation. Responses fell into 5 categories: four-year university, community college, join the workforce, join the military, or undecided. Which of the following is supported by the bar chart? And I'm going to do the best I can to get this information on the table. For category 4-year university, the number of students from Central High School was 10 greater than the number of students from Liberty High School. Now, normally, when they give us a relative frequency chart, we can't answer that question because relative frequencies show the percentages, not the number. They started off by telling us that we had 100 from Liberty and 60 from Central. So let's go ahead and try this out. So for a 4-year university, all right, well, Liberty, 20%, so we have 0.20 times 100. So about 20 students from Liberty are going to a 4-year college. When we go to Central, we're like, oh, this is about 30%. And so 0.30 times the number of students, which was 60, equals 18. And they say it was 10 greater. No, that's not going to work. The difference is 2. At Liberty High Schools, more students selected a four-year university than any other activity. So let's look at Liberty. 20%, no, that's not true. More students selected community college. For the category join the workforce, the number of students from each school was equal. And we're like, yes, the percentages are equal, and both of them had 20%, but Central had fewer students. So we're looking at 0.20 times 100 for Liberty. They had 20 students. And then we have 0.2 times 60 for Central, and they only had 12 students, so that's not my answer. At Central High School, the same number of students selected four-year university and military. All right, so let's look at Central High School. Central High School had 30% in four-year, and they had 20% in military. So that one we don't have to worry about because the percentages don't match, and we're looking at the same school. So that's easy. And then finally, we get to the last one, and hopefully this is it. Otherwise, I made some sort of error. So for the category undecided, the number of students from Liberty High School was 4 greater than the number of students at Central High School. Well, once again, they're talking about the numbers, so I'm going to have to work with the percentages. So Central had 100 students, and we're looking at undecided, which is at about at 10%. So 100 times 0.10 equals 10. And then I have to work with, that was for Liberty. And then for Central, they had 60 students times the 0.10 equals 6. And sure enough, it was the difference between 10 minus 6 is 4. And they were asking for the 4 greater. So that is my answer to number 6. Number 6 was 4. All right, moving on. The following chart shows the relative frequency of rain for 30 days in the 4 regions of a certain state. So we know that all of these were subjected, this is all measured over a 30-day period. So region D had the greatest percentage of, should go back to read this, which is not supported. So we're looking for not. I'm going to tell you, whenever they use a negative for an answer choice, I usually go through this method I call the true-false method. This will help you out on PSAT, SAT, and most any of your tests. If you just sit there and go TF, 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 and your answer will become much more apparent. Otherwise, sometimes a not supported messes you up. So please read the question carefully. But region D had the greatest percentage of days of rain. But when I look at region D, that looks like that's a true statement. That looks like that's true. It looks like they had the greatest percentage. Region B had the least percentage. Well, that's also true. Region A had more than 15 days of rain. Well, 30, half of 30 is, and by the way, I'm just saying that because we know it's over 50%. We know region A had over 50% of the time it rained. And so 50% of 30 is 15. So yeah, they definitely had more than 15 days. So that's also true. Now it was just going greater than 50%. Region C had more than 25 days of rain. No, if they don't have more than 25 days of rain. They have more than 25% of the time it rained, but 25% of 30 is not 25. So that number is not correct. And you're like, well, are you really sure, Mr. Spencer? Well, I could take 25 divided by 30, because that's how many 25 days of rain that they're claiming, divided by 30. And if I take 25 divided by 30, and I'll just get my little calculator out real quickly here, 25 divided by 30, and I end up, oh, that's 83%. This bar for region C is not over 75, so there's no way that that's true. So this looks like this is false. All right, And that's interesting because we've gone true, 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 false. So this is looking like this might be our answer. And then we get to region D has less than 23 days of rain. All right. So I'm not sure exactly what this value is, but this is about 75%. It's not quite. So let's take 75% of 30. And we end up getting 22.5. Well, if this was all the way up to 75%, they would still be getting less than 23 days. So this is true. So not supported, true, true, true. The only one that was false or different was D. So D is my answer. The region C did not have more than 25 days. All right. Number 8. The following bar chart displays the relative frequency of responses by student by grade level. And when asked, do you volunteer in community service activities? Now, notice they did not provide any information for the number, for an actual number. We don't know how many 9th grade, 10th grade, 11th graders, or 12th graders are. All we have are relative frequencies. And they're broken down 20%, 40%, 60%, 80%, and 100%. All right. So which of the following, this is a nice segmented bar chart with the no's being up top and the yeses being in the dark. So more than 60% of both 10th grade and 11th grade, and again, this is a not supported. When it's not supported, I'm going to use a TF method of breaking things down. So more than 60% of 10th and 11th graders responded yes. All right, well, the yeses are, for both of them are above, so I'm going to say that that's a true statement. It looks like that's true. 12th grade students had the least percentage of students who responded yes. And I look and I was like, gosh, their percentage is definitely lower, so that looks true. Less than 40% of the 10th grade students responded no. Well, how many responded yes? Well, more than 60. So this little no section, I'm not exactly sure, but it's definitely less than 40%. It would have to be all the way here. The yeses would have to be here for it to be 40%. So this is true. The number of 10th grade students who responded yes was greater than the number of 9th grade students. Ooh, they asked about number. I don't know the numbers of them. I don't know how many 9th graders. I don't know how many 10th graders. The percentages, yes, that might be a true statement, but the number we don't know about. So I'm going to have to give this as a false, and so that means that's looking like this is my answer. So part E, the percentage of 11th grade students who responded no was less than the percentage of 9th graders who responded no. So let's look at this. The percentage of 11th graders who responded no, and we're like, okay, so we're looking at this percentage, was less than the percentage of 9th graders who responded no. So we're looking at this. It's like, yeah, that's a true statement. So my only false statement, or the one that didn't fit in when I look at my trues and false, happened to be letter D. Okay? All right. I believe we have one more graph, which is graph number 9. A group of middle school students asked which school job was their favorite. The results are displayed by grade in the following bar chart. And I'm just going to tell you, this confuses me a little bit on this one. So I'm going to label these just to help myself out. This is 8th, 7th, 8th, 7th, 8th, 7th, 8th, 7th, 8th, 7th. Okay, so for students who chose art, so we're looking at art, the number of 8th grade students was at least 100% greater than the number of 7th grade students. So we're, and when we look at this thing, when we bothered to look at it, it says which is supported. And we don't know how many of each type were taken by, but we do. Be careful. This is number. So now we're not doing a relative frequency. This is not a relative frequency. This is the frequency. So we have 10 students, 20 students, 30 students, 40 students, 50 students. All right. So for students who chose art, the number of 8th grade students was at least 100% greater. To be 100% greater, you need to be 2 times as big. You have to be 2 times as big. Well, is the 8th grade value 2 times as big? Well, I'm looking at the 8th grade value, and I don't know exactly what this is, but I'm going to guess that this is around 18. And I know that this is less than 10, and so maybe 8. It's like, gosh, it is twice as big. And so that right there is my answer. It happened to be letter A. And whenever they do it on a positive statement, I can call it good enough. It's the negatives I work through every single answer choice. All right, that will conclude this video. There will be more videos to come. The next one will be working with tables, and I hope you will join us.